In this video, we will derive the kinematic equation of motion in a straight line with constant acceleration. As you know, when we have constant acceleration, then instant acceleration is equal to the average acceleration. So our average acceleration is equal to v minus u, and the change in velocity upon time. Here, u is the initial velocity when time is 0. So, cross multiply AT is equal to V minus U. Put U here, V is equal to U plus 8. This is our first equation of motion. Let's derive the second equation of motion. Second equation of motion is about the displacement of an object. Here in this graph, you have studied this graph in the previous videos. We have the displacement of object is covered by this area O, A, B, D, this area, and this area covers the displacement of the object. But this area has two regions, one triangle ABC and second OACD is rectangle. So S is equal to area of OABD, which is equal to the area of rectangle OACD plus area of triangle ABC. Rectangle area is base into height OA into OB. Area of rectangle is half base into height, half CA into BC. Now OA is equal to initial velocity U. Here initial velocity is not 0, it is AOA U plus OD is the time interval T. OD is parallel to CA, so CA is also equal to T. Now this BC is equal to AE, which is V minus U. Our initial velocity is OA, our final velocity is OE. So OE minus OA is our V minus U. V minus U. Now put the value of V minus U here from this. V minus U is equal to AT. S is equal to UT plus half T into AT. Therefore, S is equal to UT plus half AT square. This is our displacement of an object, and time is given, acceleration is given, and initial velocity is given. We can calculate the displacement of an object. From this equation, we will replace the value of T in this equation, and we will derive the third equation from this. Now let's third equation. Most the student gets confused in that third equation, but S is equal to UT plus half AT square. It is very simple. We have this equation A is equal to V minus U upon T. हम interchange करेंगे, cross multiply करके V minus U upon A. Put the value of T here and here. ठीक है. S is equal to U. T is equal to V minus U upon A. V minus U upon A. Right. Plus half A. It is T square. So we will put this both term in V minus U upon A in square. I am taking the simple step so that you don't get confused. U into V, UV minus U square upon A plus half A. B minus U को expand किया हमने V square plus u square minus 2uv. Algebraic equation जो आपने पढ़ी expanded. Now a is a square. Now this a is cancel हो गया इससे. Now we have here uv minus u square plus v square plus u square minus 2uv upon 2a. 2 into a. 2a. Here we also have a. Now take the LCM. 2a. Now we will multiply only these two terms by 2. 2uv minus 2u square. v square plus u square minus 2uv. 2uv प्लस में है 2uv माइनस में है, कैंसिल हो जाएगा. ठीक है, v स्क्वायर केसेस भी कैंसिल नहीं होना, तो वी विल राइट v स्क्वायर. नाउ माइनस 2u स्क्वायर प्लस u स्क्वायर, दिस इज माइनस u स्क्वायर अपॉन 2a. इधर लिखते हैं s इज इक्वल टू, हम क्रॉस मल्टीप्लाई करेंगे 2as, s इज इक्वल टू v स्क्वायर माइनस u स्क्वायर अपॉन 2a. Cross multiply, v square minus u square is equal to 2as. This is our third equation of motion. We can write it in different way also, like this. v square is equal to u square plus 2as. v square u को हम इधर ले जाएंगे तो हम राइट करेंगे v square is equal to u square plus 2as. Here we can derive the final velocity, initial velocity, acceleration and displacement is given. These are the three equations of motions. These are called kinematic equations, and these equations provide a mathematical description of how the motion of object changes with time. This is our third equation. These kinematic equations are valid only when the acceleration is constant. While using kinematic equation for motion in a straight line in one direction, remember that the distance traveled and the magnitude of displacements are equal. Distance traveled and displacement should be equal. And speed and magnitude of velocity is also equal. Speed and velocity are also equal in motion in straight line in both directions. The sign of u, v, a and s in this equation tell us about the direction of a particular quantity.